3 with the keynote speaker, Mr. Sudhanshu Saurabh. He will be speaking on the topic image extraction and identification using deep learning. Professor Sudhanshu Saurabh is Assistant Professor at East Point College of Engineering and Technology, Bangalore, with over 19 years of experience. Professor Sudhanshu Saurabh holds a MTech in Computer Science from Institution of Electronics and Telecommunication Engineers, New Delhi, and MSc degree in Electronics from University of Lucknow. He has worked at Aventure Technologies as software engineer, project consultant at Tiranga Aerospace and institutions such as RKG Institute of Technology, Indraprastha Engineering College, R&D Engineering College, Ghaziabad, and Greater Noida Institute of Technology. Greater Noida in various capacities from a lecturer, senior lecturer, and assistant professor. He has served as a resource person and has been invited as a speaker for various workshops, conferences, and faculty development programs in various universities in Noida, Dehradun, and Surat. He is a member of various expert advisory committees constituted by Commission for Scientific and Technical Terminology, Ministry of Education, Government of India. He served as an expert member for Glossary of Information Technology, Glossary of Nanotechnology, and Glossary of Insurance with CSTT, Ministry of Education. He has published 5 papers in peer-reviewed and referred journals, which are listed in SCI Index Journals, Scopus Index Journals, and conferences. He is an active member of various professional, scientific, and technical associations, ACM, IETE, ISCA. I welcome you, sir. Over to the keynote speaker.
Come forward. Forward. Come forward. The last row. Come here. Last row students, come here. Front row. Okay, this is the area image extraction. This is the area of image processing, and apply the image processing into the artificial intelligence. Okay. Hello. Okay, madam. Today's topic is image extraction and identification using the deep learning. The image processing is an area, separate area of the computer science and the electronics both. So, apply, this is application area actually. Application means the deep learning is a specific model of the artificial intelligence which is belonging to the machine learning also. So, deep learning is a very specific kind of a model in which you can train the different types of a data set. Basically, there are 4 types of a data: text data, image data, video data, and voice data. So, you can train the deep learning models using all these kinds of data. What is our job? The deep learning models, this is recently used by many different types of research organizations in US, European countries, specifically Norway and Finland. They are using, and they develop different kinds of a model. Models, what I mean. So let's try to understand what is deep learning. Our deep learning is based on the neural network, and neural network is the area of artificial intelligence. So different types of the layers in the deep learning models. Several models are there in the deep learning, like AlexNet, BGGNet, capsule network, SP network. Many types of the networks are there. Even while we are talking about the BGG16 network or BGG19 network developed by the Oxford people, and capsule network developed by the Hinton. It's called the father of deep learning and machine learning, Hinton. Recently, he resigned from the Google. So, he predicted about the deep learning perspectives. And another scientist in the Meta, his name is Jan LeCun. He said, opposing his statement, no, deep learning is okay. It will not destruct, it will not going to acquire the human resources in the industry, in the software industry, in the manufacturing industry, in the different types of the industries. So he opposes. Why I am going to mainly concern in this deep learning models? Because my research area is the deep learning, and I publish many papers with related to the deep learning, and even I developed one model. That model is called long and short term memory, LSTM model, using a deep learning techniques, and I published that paper in a Spring of Nature. So I'm going to discuss this with you. Try to understand. See, video data. I'm talking about the video data because video is little bit complex than the image and text data. In the video data, the image is there and the voice is there. Both are combined together to make a video. And images are moving. So what is our job? Classify the image and detect the image which is available in particular X and Y dimension, not in a word dimension, in a system dimension. System means the computer. The system dimension, that is x and y dimensions only. Identify, classify these two things in the image which is moving, and next thing is identify the voice also and classify the voice also. So here what I am going to do nowadays, see, whenever you open your eyelid, immediately you are receiving the informations, your surroundings. Then the information are processed in your brain. The brain is constituted by the number of neurons, and neurons are information processing unit. So those information processing unit moving, and finally you emit your voice from your vocal cord, that is called output device of the human being. That's why you take the name of that particular object, what you are perceiving, your surroundings. Like, see, the fan is moving. While we are seeing this is a fan, then immediately we say this is a fan. Why this is the fan? Because we already know in our memory, it is resides the name of this particular object is called a fan. This is a tube light and this is a laptop and all these things. So similarly, how machine will understand it? So first you identify it. You train the machine, and machine will able to respond properly. So that's why this kind of models are required. So the first thing, the video. The video is a very ultimate medium for the communication between two or more than two communication parties or the two communication peoples. So try to send the video from one location to another location. This is the first thing. Second thing, the automation. If it is automatically generated by your machine and then automatically sent from one machine to another machine, that is called artificial intelligence area of the image processing and the video processing. So that was the thing. And what is our job? Analyze the video data. How to analyze the video data? It was so much difficult. So first of all, how to convert the video into images. So for the conversion purpose, write an algorithm, write a program, and that program will take care of conversion from video to image. So that is called frame. Frame by frame you have to convert it, totally depending upon the frame per second of the screen FPS. So count the rate of FPS, and according to that, depending upon the movement of the images, the microsecond, picosecond, or the second. If it is a second, then it will take some more amount of a time. So that it's better to take a picosecond or the microsecond while you are converting from the video to the images. That's why the video is consisting the sequence of the images depending upon the time. That's why it is also known as a time series model. And according to the internet data, that 70% information means, try to think about this. The 70% information are transferred on the internet, that is in the form of a video or the image instead of the text. This is a statistical data actually. And another thing, nowadays the most widely used by the many research organizations like Google, and that is not merely a company. They are research organizations. Meta is also research organizations, and many other companies like that. So they are using the computer vision. Nowadays the one company recently they developed a ChatGPT. ChatGPT is nothing. ChatGPT is based on the LSTM models. That's it. That is one kind of a deep learning model, that is also known as the RNN, recurrent neural network. But today I am not going to discuss the recurrent neural network because it is a little bit complex than the convolutional neural network. So I'm going to discuss in the area of a computer vision and the deep learning. So how to perform these classifications and identifications. The area are the face recognitions, object detection, motion recognitions. In the medicine means like AstraZeneca, top class pharmaceutical company based on the UK. See, they develop a medicine to find the formula of chemical decompositions, draw the graphics for the chemical decomposition. For that purpose, you can apply the convolutional neural network. By this way, you can identify the images and the degree for the bonding in each image, each chemical structures. And target tracking, this is an area where I worked in one of the aerospace company. Target detection means, see, while you are developing a gun, and the camera is mounted on top of the gun, and the object is running or moving in 360 degree, then identify, locate the object, and apply. So that is target detection. This is the area of defense. Another area is the neuroimaging. So neuroimaging is also my area where I am working. And in the neuroimaging, the MRI and fMRI kind of the images. So if any kind of the problem arises in the brain, like tumors in the brain, how to identify which location the tumor in the brain. So by this way you can apply this technology, deep learning, and exactly you identify where it is location inside the brain. So see, look at here, detection of the object. See, this is a video, and in this video, two things are there: classification and identification. While you are going for the classification, classification means categorization. Category should be there. The humans are there, the trees are there, the animals are there, many objects are there. So classify those objects. So that is called classification. But identification is totally different. Identification is based on the location. Spatial data means location data. Identify which place this data is there. So identify those data using a bounding box. That term most widely used in the computer vision and for the identification purpose. That is called bounding box. This red color bounding box, value on top of the bounding box are there. Yes, of this particular object, it's called person. If he is belonging to the person, he is belonging to the human. But if it identifies some other object, then belongingness. So first you classify belongingness of that particular category, then you can identify which object is belonging to which class. So two things are there. Then that is called classification and identification. See, these are the techniques actually. So first, what you will see, all of you are the MCA student, computer science student. Try to understand these are very important concepts. So those like computer science and artificial intelligence and data science, machine learning also. See, the first what you will do, collect the data, collect the data, raw data. After that, what you will do, you will put the name of the particular data. That data is called, and huge mathematics is also required. Linear algebra and probability statistics, two things. Linear algebra, because complete deep learning machine learning is based on the linear algebra and statistics, probability theory. So, what you will do, collect the raw data, convert those raw data into a labeled data. Labeled means write a name for each and every data set. Like Excel data there. In the Excel data, what you will do, I don't have that much time, otherwise I will explain practically everything here. In the Excel data, columns are there. The column is called dimension. The name of column is called dimension and row is nothing. So by this way, you can use the real valued function. If 5 columns are there related to your data, so that what you will do, write the column name and that is real value function, then that is called capital R to the power n, where n is called number of column. If 5 columns are there, then that data is called 5-dimensional data. That is called dimension. So after that, what you will do? This is called labeling. Write a name, label, name of each and every cell which is available in the Excel data. Okay. And one more thing, what do you do? Data cleaning also. Clean the data. Data you have to remove. Okay. Sometimes data is not available. Some rows are available, but in the cell data is not available. Then what you will do? That function is called fill function in the Python. By this way, you can insert the zero value instead of the not available data. By this way, you can clean the data. So that's all this process is called labeling of the data. The first step, this one, labeling of the data. And after that, what you will do, develop your own model. That model is called deep learning model. Develop your own model or algorithms. You can say algorithm also. So apply this data in your model and train the model. If model produces a proper result, then okay. If it is not producing a proper result, then again remodel. Remodeling is required. That's why deep learning and machine learning is difficult because of this. Because modeling of the model is so much difficult. Use mathematics are required because so many hyperparameters are there, learning rate, hyperbolic functions are there, and activation functions are there. Many types of activation function. If one function is not working, then you can use another kind of a function. So try to learn the activation function and that activation function belonging to the neural network. That's why it is called deep learning model. And sometimes it is called a deep neural network or the convolutional neural network, a recurrent neural network, anything. So these are called the model and algorithms. Develop your own algorithm according to your data and the inbuilt algorithms. Inbuilt algorithms are properly fit with your data, then what you will do? No need to change. But if it is not properly fit, then what you will do? Change the algorithms. Inbuilt algorithm, modify the algorithm, perform some changes in the algorithm, and then train with your data. And the next step, region proposal network, RPN. Next, the RPN is a very important concept developed by one top class company, Microsoft. That is called that model and algorithm is known as a COCO model. That COCO model or the algorithm you can apply, but it's better to use the RPN network and faster RCNN model instead of the COCO network. COCO is not that much useful. It takes a huge amount of the memory in your system, but it's not that much useful. So better to use the faster RCNN along with the region neural network, RPN network. So, right, once you are completing all those things, two techniques are there. I'll just for the region particular. After that, what you will do? Create a bounding box. Bounding box means, see, this red color, these boxes, red color boxes, these are called bounding box. So, develop a bounding box. After that, this complete process combined together, algorithm, RPN, and bounding box all are combined together and sent to the another step. That step is called feature visualizations or visual features. Because images are there, video are there, then visual features are itself there. So visualization of the features. Features means numerical value data, numeric data. And for numeric data, either if you are using a Python, then in Python, NumPy library is there and SymPy is also there. So NumPy is responsible to convert the image value into a numeric data. Understand? That numeric data means image consisting of pixel. The pixel means numeric value, binary value. So that what happens, those pixels are converted, taking care of the NumPy package, converted into a Python values, Python kind of a numeric value. So that's why the NumPy packages are required. After that is called the feature. And after that, what you will do? Process the data. Processing and then you'll get the result. But problem is there. The two bounding blocks are overlapping with each other. See, person is there and he is wearing a goggles. So our job is to identify the goggle and person both. Understand? to draw the bounding box around the goggle and on the person. So two bounding boxes are required, but they are overlapping with each other. Problem arises, overlapping. How to remove the overlap? Euler-Jones algorithm is there. Hard cascade algorithm is there. That is inbuilt algorithm. What you will do, simply you download, go to the net, download hard cascade.xml file, you download and set with your environment variable, where Python are stored, environment variable. So that's why I apply the environment variable and set that path, hard cascade.xml. I'll show you. And that algorithm, Euler-Jones algorithm, so both are taking care of the overlapping scenario. See, these much algorithms, fast RCNN, faster RCNN, R is stand for region, C is stand for convolution, N is stand for neural, and another N is stand for the. So faster RCNN, fast RCNN, some small modifications are there for the purpose of anchor box and the bounding box. Histogram oriented, most widely used by the students community only, not by the industry. Student community, they are using a HO, that is simply just a hog algorithm or histogram oriented algorithm. So gradient is three types actually: Laplacian, Gaussian, Slovan, Prewitt, types of algorithm. And reason based RCNN instead of faster RCNN. In the faster RCNN, RPN network are there, but in RCNN remove the RPN. And why RPN? Because RPN is taking care of the sliding window. So it's better to remove the sliding window. Then the fast RCNN becomes a RCNN. And another algorithm you can download. These algorithms you can directly download from the internet. It is freely available. So you can download. Essentially single shot detector algorithms. You can apply this algorithm, but everyone should know the environment, how to set the environment variable path. Another model along with the algorithm that is called SPP network. Net. Shortly we can say the SPP net. Spatial pyramid. It's location. That's why it's spatial. And YOLO algorithm. And YOLO algorithms that is given by the Darknet. Darknet is a company name. So most widely used algorithm nowadays I saw they are using the company they are using nowadays two algorithms. Any one of them, they are all good algorithms. See how to convert the video. Now we're starting the process. How to convert the video into an image. See, these are the procedures. So first, what you will do, collect data, then extract the feature. The two techniques are there, the frame and the video. Two things. Only image are there, no problem. Directly you can go by the left hand side. Video is there. Then what you will do, apply the machine learning and non-machine learning models. Two things. Machine learning model, not if image only, then what you can do to use machine learning and non-machine learning again, but steps are more. Many more steps are required to convert those images into a form of a detected data and the classified data. See, the faces, human, object, emotions, many things. Recognize this, classify this. And similarly, in the non-machine algorithms, it takes much time, longer steps, number of when you are writing a program, then it takes longer code instead of this machine learning models. So, by this way, and if there is a non-machine learning models, then the quality, the color, characteristics. Basically, there are three basic types of error are the CMY. Basic types. There are two and CMY. Cyan and alpha. So by this way, you can use, but it's that will not produce a proper result. So better to use a machine learning model instead of the non-machine learning model in both the cases. That is images and videos. So look at here. See, this was I developed. Next time any kind of this kind of activity will conduct, then I will show you how to convert. Practically, I will show you. Come with your laptop. Huh? See, these are the video data set. These are the video data set. Huh? Select any video randomly. Select any. This is in your secondary memory in your system stored. Select any video randomly. What you will do? Apply here the framing algorithms. Apply here the framing algorithms. This step, video data is there, framing algorithms are there. Then your that algorithm take care and it will convert the video on the basis of time. The time before microsecond and convert the thousands, millions of the images for this particular 5-second video, 5 to 10-second video. Millions of data will generate. See here. That is called a frame sequence. And after that, what you will do? Apply some specific kind of algorithms again. Next step. That is called contour generation or the bounding box, or you can say the anchors. So the three names are there. Contour is a 40-year-old word. Contour, developed by Privet Sobel. These two computer scientists and mathematicians, they developed this word contour for this specifically for this kind of image identifications. So that's why contour is in the different. That is old word, but in the context of image identification, this is new. So generate the contours with a particular image. You write an algorithms. Mathematics are there everywhere available, but you can convert those mathematics into the algorithms and then write a program of that algorithm, apply that. Then you get the result. See what is the result. See, this way. The one edge data technique is called tiny. Tiny is the name of scientific. Tiny expression technique. In the tiny, what you will do? Import OpenCV, add CV2, then add CV2 dot Gaussian blur. The Gaussian function, which is most widely used in image processing, the function which is available in the Python, that function is called Gaussian blur. Apply the blur in the image. How? CV2, that OpenCV function, Open Computer Visualization, that company name. The company name is here. So, like this way, see the image completely blur and apply the tiny. Both are producing the same result. The tiny function is also there. Now, HOG, histogram oriented. See the same image, HOG, the blue color edges are there around the images and the object. See, three functions are there. What kind of the functions you like? The three kind of functions are there. Anyone, if you like, you can use, and it will generate the edges around the images. Another kind of a function. See, check this. This similarity between this comparative study. See here, detect the contours. How you will detect it? The dilation is there, the find contour functions is there, draw contour function, arc length, many things are there. Many functions are there which you can easily from OpenCV library. First to download, set the path, and you can use it. See, Look at here. The identification. Image. This is a video data. Thousands of people are there identifying a single image using your camera. How to identify? Look at here. Load the image. Convert. After conversion, then apply the Har cascade. Har cascade.xml. Just now I told. Har cascade.xml. That file will take care of this identification. You download and set it the path of required. And after that, face identification is there. And face descriptor script should be there. These three things combined together, and then it will extract the bounding box images here. See how nicely these algorithms are taking care. But problem is there. Problem is overlapping. See, one bounding box is there, another bounding box is here. Then it creates a problem. So, what you will do? Apply the Euler-Jones. After applying the Euler-Jones, you will get the proper image of that any image which is selected, randomly selected. Random selection, for that purpose you learn the probability. Random space. Select a random image. For that purpose, statistics and requirement. So what you will then identify the different images. See, these are the features in the image. This is a image, RGB model, RGB color images. The color are available between a binary value 000 to the 111. 00 stands for the black and 111 is stand for the white. All the color is reside between binary value 000 to 111. Understand? So both we can use. This is a RGB, a gray image, black and white only, and RGB color. So you can apply both. By this way, if you are applying the gray, then image details are like that. But if you are applying this color, then the color intensity are showing here. This is the distribution of green and blue color in this particular image. So by this way, numerically, you will get the data and converted by the OpenCV along with the NumPy library. These two things. So this part is over. This is the step one. This is step one, not over. So come to the deep learning step. Second step. The first step is over. Identification, okay, but how much percentage of this image is belonging to that category or that class? Getting my point? Question is this. So train that model, train that image. How to train? It's up to you. Machine learning or deep learning, two different things. So machine learning is not giving it that much exact. Machine learning models are good, but not so much good. That's why the deep learning is required. So you can apply the deep learning models on those trained data, identified data, and train that data. So everything I discussed is related to the deep learning. See, the brief overview of the deep learning models. According to the Moore's law, deep learning is going so fastly, red color line C, so fastly. And some older algorithms, machine learning, that is going by the green color. This is the prediction of the performance of the deep learning. The performance, why deep learning is going so fastly? It is complex, but growing so fast. Why? Because, see, that ChatGPT. Nowadays, ChatGPT in this position they are going to beat the Google within next 10 years. Why? Because whatever you want, you write, and immediately a source code or any program or slides, PPT, anything, simply you type and it will generate. Why? Because with complete changeability is based on the LSTM model, deep learning models. So that's why it's a growing fastly. See, the area, the speech recognition, natural language processing, recommender systems, discovery of new drugs, and pattern recognition. These are few areas where you can apply the deep learning models. Last week, I am given one assignment to my students, write a program for the recommender system. Because this semester I am taking the data science course, so I am given this develop a recommender system assignment. So, see these two aspects. Now, come to the technical aspect. If you are technically sound, then you can develop anything, mathematically and technically. Two things. Your mathematics is strong and your technology, the programming, if two things are strong, then you can easily excel in deep learning field. Two things. This is a neural network model. Neural network is here. The neurons are here, machine neurons, not human, but it is directly mapped from the human to the machine. Inside the human brain, neurons are there, they are connected with each other and process the information. The neurons do information processing. Similarly, inside the machine, if machine behaves like human brain on the basis of neural network, they are connected with each other. So, that kind of a model is called a neural network model. They are connected with each other. All the neurons, circle, the symbol is shown by the neurons, symbols are shown by the circles. They are connected with each other, sir, and process the information, sir. So after processing, the final circle, final layer generates the output. But problem is there. Output is okay, generated by the neural network, but that is not desired output. If it is not desired output, then what you will do? Problem. Desired output you are not getting. See, for example, the Google search line or ChatGPT search line, whatever you are typing, you are not getting proper result. Then what happens? Again you are writing, hmm? Again you are writing, again searching, the same thing. Because this is a human phenomena, human psychology. If you are not getting a result, then again you are typing, again you are doing something. So many times. That is called feedback, repetition. Similarly, the same thing you have to apply in the neural network. If desired result you are not getting, then you will do the output against feedback, again gives the input. Then what happens? Output minus computed result, desired output minus computed result. If both are same, then result will be zero. It means that you get the proper result. But that desired result minus computed result with some numeric value that is equal to some numeric value, it means that that much percentage the data is not matched, not computed. That much error. And again, feedback we calculate. Simply you think how much processing are required in the neural network. The capacity, the simple kind of a computer is not able to perform that kind of a computation. So better to use the GPU based laptop or machine of the simple type of a CPU based laptop of the deep learning and machine learning models. And this one is a application identified. This is the first application of the neural network. First application. The numbers are there. The numbers in the form of image. The pattern of numbers are correct or not. This is the first example. solved by yeah, Google LeanNet. The deep learning model was Google LeanNet. Earlier it was known as LeanNet model. You can check on internet. You can check on Google. It is available. So trained by this. See, this is a development of the deep learning. It started from 2013 to 18. In 18 it was stuck. No new models are there. For the detection and identification purpose. For detection and identification, these two things I am talking about. For that purpose, the neural networks, algorithms, and the models started from 13 to 18. These many models are there. RCNN, multi-box, net, faster RCNN, YOLO, many algorithms are there. ComberNet, RetinaNet, DenseNet, you can use. But try to learn the TensorFlow and Keras along with the PyTorch. Because they see these all models are implemented in a TensorFlow, which is based on Python, Keras, which is also based on Python, PyTorch, which is also based on Python. So you can use all these three and implement these algorithms. You can change them. Also, see, the TensorFlow is a product of Google and PyTorch is a product of Meta. But PyTorch performing much better than the TensorFlow. See, when you are using Facebook, all the data analytics are performed by the PyTorch. See, when you are clicking a like button, how many data are generated to do? The emotions related to that particular image, your emotions is related to that particular text. Why you like this text? Analytics are there inside. That simple one click performs a huge amount of the data. On the basis of that, like the information from the Meta, from the Facebook, that is called recommendation. Understand? So that is also known as a data related to the single click of the like the social media. Understand? See, deep neural network. It is there in the neural network, get the result, classify it, and some specific mathematics are there here. Inside the deep neural network, the input data, output data, and the processing data, all these three things are there. Different types of a neural network is there. Multi-layer perceptron network is there. That is also known as a Maculo-Pitt model. Multi-layer perceptron. Another layer, complexity increase. Two-layer model. This is two-layer, input, output, that's it. But increase the number of layers, that is called depth. That is a CNN, convolutional neural network. Input layer, output layer, n number of hidden layers, that is called depth of the model, CNN. And next, RNN. This is complexity of RNN. And recurrent neural network. Why? Why it is complex? Because there are much hardware are required to create a neurons. See, input layer, input gate, output gate, forget gate, combined, and also error correction. CRC is also required. Once CRC comes in the recurrent neural network, then it becomes a LSTM. So that's why this model is going to develop a LSTM. See, framework is required. This much framework are used to implement the deep learning models. PyTorch, MXNet, Chainer, Paddle, MATLAB, Caffe, Theano, TensorFlow, Keras. So nowadays most widely used these three models: PyTorch, Keras, and TensorFlow. Theano is outdated. Keras is outdated. MATLAB is not that much. Few people are using MATLAB, and these are also Chainer is good, but MXNet, use MXNet, but not just widely use this framework, and idle pattern is also not widely used. Only few researchers they are using this. So this is a deep learning framework. See, what is it? If it is interesting, I'll okay. See, look at here. Object now framework is okay, model is okay, model you know, framework you know. Once model is there, then come to the framework. Apply that TensorFlow Keras, both are combined together. Because TensorFlow is the back end, Keras is the front end. Okay. Otherwise, if you don't like TensorFlow and Keras, then you can use PyTorch, product of Facebook or Meta. So, how to detect it? The first technique is HOG, scanning, Gaussian blur. Many techniques are there to detect it. But once you train the data inside the machine, inside the model, then what model, deep learning model, then what deep learning model will do? Deep learning model requires a faster RCNN and YOLO, COCO. These models are required for the deep learning. Be clear. HOG, Euler-Jones, Gaussian blur, Canny algorithms, Prewitt algorithms, Sobel algorithms. That is older model. Come to the latest model. These are the latest model. Faster RCNN, YOLO, COCO, SSD, single shot SSD. These are the latest models. So these are all based on the deep learning. That's why it's better. The performance is better. So this is called this image is called the region proposal network RPN. This is a model. Here, anchoring box are here. Three types of anchoring box. There is some ratio between the anchoring. Anchoring means the bounding box. You can say while you are using the deep learning, that bounding box becomes an anchoring box. Once it becomes an anchoring box, then height and width. They are two different. So while you are developing the anchoring box, so what you will do, first you check the width and the height. The ratio is, if it is square bracket, then ratio is called 1:1. If height is more, width is less, then you can say 1:2 kind of a bounding box required. And similarly, 2:1 kind of bounding blocks are required to train in the RPN models. The image is here, convolutional layers are here, feature maps numeric value are here, RPN is here. This RPN, this is called RPN, region proposal network. That is here. That complete diagram. And region of interest, ROI pooling. It pulls the interest and then fully connected, or you can say the dense layer. Dense layers are here. Then you will classify and generate the bounding box. This is called classification of the image belonging to that particular category and specific data, that bounding box, B box. It is called B box. So by this way, this part is called identification. This part is called classification. See, these are called the anchors. Square 1:1 ratio. 1:1 ratio. This is called 2 width into height. Width versus height. 2:1. So this is all 2:1. Total 9 bounding boxes are available in the faster RCNN model. These are all 9. And this is a 1:2 ratio. 1 is small, 2 is bigger. So this is available, already available in the model. And by this way, it will generate In faster RCNN, what is the use of RPM? This is a matrix for bounding box. Okay, matrix with thousands of matrices are there. So these bounding box slides, one processing over, then it will slide further. So that's why it is called a sliding window of the this bounding box. So okay, that much. Okay. So what you will do? Install in your system Python first. Second, it's up to you. PyTorch you like, then you can install PyTorch. Okay. If you don't like PyTorch, no problem. Use TensorFlow Keras, both together. And CUDA toolkit. CUDA is some specific kind of the hardware. That toolkit is also necessary along with the software. So it works with NVIDIA GPU based system. CUDA. You can implement CUDA in C, C++ also and Python also. No problem. So install the CUDA. And then this algorithm, after RCNN algorithm, it is necessary along with the RESTnet. RESTnet it is kind of available in the internet. You can download. And single algorithm. Detection algorithm for the multi-box generation purpose. See the result. This is a complete framework of the data. Here, raw data, some libraries, that Python libraries are here, converted into images. This video converted into images. After that, faster RCNN along with the region proposal network here, and then it will generate the numerical value along with the name. Here, it is not properly visible actually, but here the name of the images, tree, bag, backpack, shoes, trouser, everything you can detect with their probabilistic value. That value is called numeric value. The name here, and along with image which is bounding box, the blue color bounding box around each and every object it is generated. This is the final framework complete. And okay, see, this is this is implemented by me. I implemented this. Yet I implemented the city buses are here. The bus is standing in the road. Count the number of persons, identify each and every person, count the person who is sitting inside the bus, and identify. Everything is performed by this neural network algorithm. That detection. Index. Next time, come with your laptop.